Alrighty, here is the key to the review for your first test. Alright, so we're starting with domain and range. So remember, left to right, bottom to top, you always write these intervals, least to greatest. And these are going to be an interval notation. That's what I want for all of this. So as my domain, the smallest x value that I have is 1, 2, 3, 4, negative 4. Then I use all the x values all the way until positive infinity. You never include the infinities. Negative 4 is an x value on my graph, so that's my domain. My range, you go from least to greatest. So since this keeps on going this way, the smallest y value I'm going to have is negative infinity. And I use all the y's all the way up into, that's going to keep going all the way into infinity. And you never include your infinities, so those are both parentheses. I know that one doesn't look like a parenthesis. Don't there be any confusion. Okay. I'm also going to ask you on these whether or not these are functions. This one fails the vertical line function. So this is not a function. All right, this second one here, domain. So first of all, I have asymptotes here. So I have an asymptote here at 0 and here at 0. So I always draw mine in so I can count and look at my graphs correctly. So I start way out here for domain, start here at negative infinity. I use all the x values till I get to 0. So I'm going from negative infinity to 0. Never include my infinities. I'm not going to actually make it to 0 because I have an asymptote. Then I start back over on the other side of 0 and go to infinity. I have to union those. And it looks like that. Range, smallest y value, negative infinity, all the way to 0. Both of those are open because I have an asymptote. And then I start back over at 0 and go to infinity. And this one does pass the vertical line test. Oh, draw lines, but so this is function. Alrighty, this next one. My smallest x value I have is a negative 3. Go all the way until here, so that's 1, 2, 3, 4, 5. I do not include the 3 because it's open. I do include the 5 because that's an actual x value that I have. My range, bottom to top, 1, 2, 3, 4. My smallest y value is negative 4. Keep going until I get to 0. I do include negative 4 because that is a y value that's plotted. I do not include 0, and it's open. And this would pass the vertical line test, so this is a function. Here we go. All right. So I need to evaluate. Remember, when you do these, or really most anything we do, the first step is 0 work. You just substitute it in. Your notation matters. H of negative 6, which is what I'm looking for, that's equal to negative 6 cubed minus negative 6 squared plus 4 times negative 6. Okay? So a negative value cubed is still going to be negative. 6 cubed is 216. Minus negative 6 squared is a positive 36. And then 4 times a negative 6 is a negative 24. Okay? So I combine all those. I think I'm going to combine these two first. So I get negative 216. It's going to be 50, 60 minus 60. So that means that h of negative 6 is equal to a negative 276. All right, for this next one, I want to find f of 4x. That's equal to negative 4x squared. Notice I'm substituting that in for x, so this negative stays out front. 4x is what's getting squared, plus 5 times 4x. So this is equal to negative, because I just bring that down. 4 squared is 16, x squared is x squared, plus 20x, and I'm done. Okay, let's talk about the next step. Some of you went on and did negative 4x, and then 4x minus 5. That's not wrong, but you don't have to do it. This doesn't say anything about factoring. We're just evaluating. So although this is not wrong, I would caution you against going another step, because if you make a sign error or any other kind of error, then you're just wrong. Whereas if you'd have stopped, you'd have been right. So that's really the better answer there. Okay. All right, let's look at factoring. Factoring a trinomial, a is 1. You can just jump to 2 sets of parentheses. This is x, this is x. This is negative, so my signs are opposite. I need two numbers that multiply to give me 27, subtract to give me negative 6. So that's going to be 3 and 9. This is negative, so it's a negative 9 and a positive 3. Some of you have 9s and 4s that look very, very similar. I'm not going to play the whole handwriting analysis game. If it looks like a 4 to me, it's a 4. If it looks like a 9, it's a 9. So be careful. All right, so this next one, they're not numbered. This is, a is not 1, and I cannot factor out a GCF, so I'm going to multiply 5 times 3, and I get 15. This is positive, so the signs are the same. So that means I need two numbers that multiply to give me 15, add to give me negative 8, so that would be 3 and 5. So I'm going to have 5x squared. All I do right now is split this middle term, so negative 3x minus 5x plus 3. And at this point, I want to make sure when I combine that back together, I get a negative 8. So I'm good to go. I'm going to factor by grouping. So I can factor out an x. That leaves me with 5x minus 3. Out of these two, I can factor out a negative 1. That leaves me with 5x minus 3. Gives me x minus 1 times 5x minus 3. And that's it. I'm done. All right, so here, a is 1, and I think some people make this out to be way harder than it really is just because it's the next to the fourth. This is actually easier than this one. I treat it just like this one. A is 1, so I can start off with 2 sets of parentheses. Instead of x and x, I have x squared and x squared. This is negative, so my signs are opposite, a plus and a minus. So I need two numbers that multiply to give me 16, subtract to give me a negative 15. So that'll be a negative 16 and a positive 1. I can factor this some more. I cannot do anything with this one because there is no such thing as a sum of squares. So that stays x squared plus 1. This becomes x plus 4 times x minus 4 because it is a difference of squares. And that's that one. This one, again, people make out to be way harder because it's got a cubed and there's 4 terms and oh my goodness. It's easier than this one because on this one we had to split the middle term to get it into 4 terms. Then we factored by grouping. All this is factoring by grouping. So I factor out an x squared. That leaves me with 4x plus 7. And then here I can factor out a negative 7. That leaves me with 4x plus 7. So I get x squared minus 7 times 4x plus 7. And this is not a difference of squares, so I can't do anything with it. That's my answer. One thing that greatly helps you with your factoring skills is knowing your multiplication facts. Just a little FYI. All right, so now this is a sum of cubes. I start off by doing a binomial and a trinomial. And then I use SOAP. Get my signs in there. Same, opposite, always positive. This is plus, so this is the same, opposite, always positive. I take the cube root of this term, that gives me 3y, that goes right there. Cube root of this term is 2, that goes right there. To get this one, I square this, so this will be 9y squared. To get this term, I multiply these two together, so that's 6y. To get this one, I square this, and it's 4. And that's my answer. Here I have a difference of cubes, so I start off with a binomial and a trinomial. And I use SOAP. Same, opposite, always positive. This would be x and 5, because those are the cube roots. And this is x squared plus 5x plus 25. Even if you're struggling with any of this factoring, I would suggest you go back to that Delta Math assignment and redo some stuff without your notes. Like, even if you already did it and you got 100, you may need to go back and practice some more. All right, x and y intercepts. Intercepts are written as ordered pairs. Okay, so here's my x-intercept, here's my y-intercept. So my x-intercept, I only have one in this particular case, is at -3, 0. My y-intercept is at 0, 3. When you're asked for intercepts, they are ordered pairs. When it asks you for zeros, they are sets of numbers. So it says algebraically find the zeros in the y-intercept of the function. Well, guess what you have to be able to do this? You have to be able to factor. Okay, so we're going to factor. There is no GCF. A is not 1, so 2 times -5 is -10. So I need two numbers to multiply to give me -10, combined to give me 9, so I can split that middle term. I get 2x squared plus 10x minus x minus 5. I'm going to factor by grouping. These two, setting that equal to 0. These two I can factor out of 2x. That leaves me with x plus 5. Out of these two, I can factor out a -1. That leaves me with x plus 5. So I get 0 equals 2x minus 1 times x plus 5. So to find my zeros, I set each one of these equal to 0. So 2x minus 1 equals 0, and x plus 5 equals 0. So x equals 1/2, and x equals -5. So my zeros are -5 and 1/2. Notice those are not in ordered pairs. It is a set of numbers, so I put them in my little squiggly brackets. There are my zeros. My y-intercept comes from f of 0. And f of 0 is 2 times 0 squared plus 9 times 0 minus 5, which means f of 0 is just -5. So my y-intercept, which is going to be an ordered pair because it says intercept, is 0, -5. There you go. Okay, last little section here. It says, given the coordinates and, bad wording, I should say give the coordinates and classify the critical points for the graph of the function, state the intervals on which each function increases of decreases. Wow, that's just all kinds of bad. But I think you know what you're supposed to do here. All right, so first, the critical points. And again, your pictures are going to be way better on your tests, so you don't have to guess at this stuff. But, oops. So if we have this point right here, I have 3 critical points. The one that's missing from this graph is the point of inflection. So make sure that you do know also what a point of inflection looks like. So we're going to have to say if it's kind of in the middle, we have an ordered pair here. This is going to be my absolute minimum, is the smallest on all of them. So absolute minimum. And that ordered pair is going to be at -0.5, -1, 2, 3, 4.5. Okay. Then I also have this point right here, which we'll say is at 1. I'll say that hits it. If you did 1.5, it's fine. But 1, 2, 3, 4, 5, 6. So I have a relative max at 1, 6. And then this point right here is going to be a relative minimum. And that is at 1, 2, we'll say 2.5, -1.5, -1.5. Okay? Alrighty. So now my increasing, so those are ordered pairs. Those are not intervals, even though my ordered pairs and my intervals look very similar when they are open intervals. So we're going to look at increasing intervals. I'm increasing from here to here, then I'm also increasing from here to here. Okay, so I start increasing. Now I'm talking about my y's are increasing, but my intervals, I write intervals of the domain of x. So we'll say that that's start at negative 0.5, and I increase until I get to 1. Okay, they're both open, okay, and that should be, remember curvy parentheses, my board just doesn't always like to cooperate there. There we go. And then I'm also increasing from, let's see, 1, like 2.5 all the way to infinity. So I'm talking about y, I am writing about x, and then I have 2 intervals, I have to union them. Then my decreasing intervals, so my y's are decreasing here, and my y's are decreasing here. So I start decreasing when x is way out here at negative infinity. Never include the infinities. I keep decreasing until I get to here, which is like negative 0.5. And I'm going to union that with my next interval that starts at, we'll say that starts at 1, and we go into 1, 2.5. Remember, I'm telling you to kind of guess off this graph with the 0.5s because I know I gave you bad graphs, but we don't normally get to guess off graphs like that. All right, so that's increasing and decreasing. Now I got to look at positive and negative. So positive, that's everything above the x-axis. That's all of this. So I have 3 intervals that I union together. Looks like I start way out here at negative infinity. All of that's positive, so negative infinity. And then I'm positive until I get to like negative 1.5. Remember, we definitely don't include that because if we included that, we'd include 0, and 0 is not positive or negative. Then this is going to drop below the x-axis, but then right here, again, starting at 0, I'm going to be positive until I get to here, which will say that's, what, 1, 2.5. And I union that with that third one that starts here at 1, 2, we'll say 3, and goes to infinity. Okay. There won't be any guessing tomorrow. The pictures will look good. Negative, I'm here and here. So I start here at negative 1.5, and then I go to 0. And I'm going to union that with 1, 2.5 to 3. Okay. If you still have any questions, you can come to tutorials before school tomorrow or MAV time, because we do have MAV time tomorrow. Remember, you can always go back and work more stuff on Delta Math. I did realize after I did this, I didn't put 1.1b on here, but you had a quiz on it, you have notes on it, so go back and make sure you understand how to get those questions right on the quiz, look back at your notes. For all of this stuff, look back over your notes, go back through some assignments, go back and look at those quizzes so you don't make the same mistakes more than once, or if you didn't make any mistakes, that you do what you did so that you don't create new mistakes. Okay, so please come ready for this test because I think you have opportunity to do very well. And remember that I am also grading your ISN, so don't forget those.